For this question, we have to graph y equals 2 times sine of x. But before we do anything, let's systemize our plan of attack. I've broken down answering these types of questions into 5 different steps. Step 1 is to identify the variables a, b, c, and d. Remember, these are the variables that we found when transforming our function into general form. Step 2 is to calculate the period. Remember how we can calculate the period. We take 2 pi and divide it by the absolute value of b. After we calculate the period, we have to calculate the period divided by 4. You'll see how that comes in handy later. Next, we're going to find the starting point. What is the first point of our graph? The only thing that should affect this is whether there's a horizontal or a vertical shift. The fourth step is to find the other 4 critical points. Remember, there are 5 critical points. The first one is the starting point, and the others can be found by using the period over 4. The last thing we have to do is draw the points and then connect the dots. So let's get started. Step 1 is to identify my variables. So the first thing I should probably do is take this function and transform it into its general form. After we do that, we can see that a equals 2, b equals 1, c equals 0, and d also equals 0. Step 2 is to find the period. Remember, we can find the period by taking 2 pi and dividing it by the absolute value of b. In the previous step, we found that b was equal to 1. So to find the period, we take 2 pi and divide it by the absolute value of 1, which is just 2 pi. So what does this mean? This means it takes a distance of 2 pi units across the x-axis to complete one full cycle of our sine function. Remember what one full cycle means. It's the unique section of our graph that doesn't repeat itself. Here we have one full cycle of our sine wave. It starts by going up, then goes down, and then goes back up again. Its period is 2 pi. This means from our starting point, it takes a length of 2 pi to get to our endpoint. So it's the distance of this blue line. After we find the period, we have to find the period divided by 4. So if the period is 2 pi divided by 4 is pi over 2. Step 3 is to find our initial point or our starting point. For our sine function, if there's no horizontal or vertical shift, then the starting point is the same as the original function. So what is the starting point for sine of x? Well, if sine of 0 equals 0, then the starting point is at 0, 0. We can also use the unit circle to help us understand this. Remember, for the unit circle, the y-coordinate is representative of sine of our angle. So what is sine of 0 degrees? Well, it's 0. That means sine of 0 degrees equals 0, and our starting point is at 0.00. Now here's where it all comes together. What we're going to do is we're going to find the 5 critical points. But for each point, we're going to find the x-coordinate and y-coordinate separately. So right now, we're only addressing all of the x components. Let's start with critical point number 1. Critical point number 1 is our starting point. We already said in the previous step that our starting point or our initial point is at 0, 0. So therefore, the x component of our initial point is 0. Now finding the x-coordinate for all the other critical points is very easy. You start with the initial point and you add to it the period over 4. Remember, we calculated the period over 4. It was pi over 2. So to get the x-coordinate of the second critical point, you add pi over 2 to 0. To find the third critical point's x-coordinate, you add 2 pi over 2's to the starting point. For the fourth critical point, you add 3 pi over 2's to the starting point. And for the fifth point, you add 4 pi over 2's to the starting point. So all you're doing is you're incrementing each point by pi over 2. This tells us that the x-coordinates are 0, pi over 2, pi, 3 pi over 2, and 2 pi respectively. Next, we're going to find the y components. In order to find the y component of each critical point, we have to consider the function we're graphing, which is 2 sine of x. What we're going to do is put each of these x coordinates into our function. So the y coordinate for the first critical point is 2 sine of 0. The y component of the second critical point is 2 sine of pi over 2. And the third critical point's y component is 2 times sine of pi, and so on and so forth. The only challenging part of this step is that you have to know what sine of 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, and sine of 2 pi are. So this takes some memorization of the unit circle. If you don't memorize the unit circle, you can't proceed further than this part. So make it a high priority to know. Alright, so now we found out that the y coordinates are 0, 2, 0, minus 2, and 0. Therefore, our critical points are at 0, 0, pi over 2, 2, pi 0, 3 pi over 2 minus 2, and 2 pi 0. And now for the last step. All we have to do is plot these points and then connect the dots.